Hey guys, it's J-Doctor. Today I have a brand new data pack that I made and spent a lot of time on, and I wanted to release it for you guys because I think it's pretty cool. So this is WASD detection with a data pack. I think this is the most accurate version that I am able to make right now. So I wanted to show you how to use it. So it's actually really easy to use. I've made it in a way so that you can add it to whatever creation you want. So if you're like wanting to have all the players walking, like as soon as they start walking, you do something. I don't know. I don't know what you would want to do with it, but I made this. So it's very simple. All you need to do is when you put in your execute commands, so as at A, I've made it so you can use a predicate. So you can just go predicate, and then you'll get this list of predicates. So you can do WASD W, and then run, say, forward. And then you can add the switch, and you can see I'm going left and right, nothing's happening. So I can walk forward, and we get our message. And it actually outputs once every single tick, so it's pretty much a constant output if you're just holding it down. You can change whatever key it is. You can do, if I'm going left, here, let's do this. We can go W here, and we can do left. And now we have both of them, and they both work together at the same time. And then we can do right, and we can do backwards as well. So now we have a message for whichever output we are clicking. The other ones you can see that I have included is shift and space, and then we have moving and falling, which isn't really as important. So if I got one and I said space, then we can do like jumped. Whee! You can see like spams as much as I'm actually constantly moving up. So it actually doesn't use a jumped scoreboard that you would expect because it's very picky with how it works. So I'm just using some commands to detect if you're moving up like at all in the slightest, and that's your jump. So that's our detection. And the other thing that I've added for this data pack that will probably be very useful, like let's say you wanted to make an adventure map or something and you wanted to make like a custom menu or something, you can go function WASD and you can say lock or unlock. And what this will do is if I run this, it will freeze the player completely. I can try to turn and it'll keep teleporting me back. It will freeze us in place and it will still let us do our outputs. And you can see the screen is really not moving at all. This is something I really wanted for a long time, where like if I wanted to, let's turn this off so it's less distracting. So if you wanted to make like some kind of like adventure map or like recreation of a game or something, and you wanted WASD detection, but you want the player to hold still so it looks like you're just in some other game, you can just run this command wherever the player is, and it'll lock them completely in place. And it doesn't matter which direction they're looking either. So like I could look like directly at the sun or right at the ground, and you can see that we are getting our outputs, but there's no movement like at all. So yeah, I'm really happy with that. If you look up, you can see a little bit of what's happening. There's actually a shulker up here. I can explain how that works in a little bit. But that's super useful if you want to do that. The other thing that you can do is, let's say you wanted the player to move over to here. We can grab the coordinates for this block. Then we can say execute as at A. You want to specify which player you want it to happen to. So this is multiplayer friendly, by the way, too. So if you wanted like one person to have frozen, then you can freeze them, and each player will have their own WASD output. So if someone else is pushing W and someone else isn't, then it will know that. So you can go as at A, positioned, and then your coordinates. And then you can put rotated if you want like a specific rotation. You can go like say we're looking directly at the ground, I believe is -90, right? No, it's positive. So it's rotated like perfectly looking south and perfectly looking at the ground. Then we can run that same function, WASD lock, and you can see it teleports us over here and it's still working. So yeah, that is our little system that we've made. And so yeah, if you want to use this for your data packs, I will show you how to install it really quickly. So I'm going to assume you know how to install your data pack by putting it in your world save. So the download you're going to get is going to include the data pack and a resource pack. That's for a little fancy thing I'll show you later, but the resource pack is not required at all. So you're just going to drag your file and just throw it in your data pack folder, and then you just type /reload or eload. You're going to type /reload, and then you can hide the message so that every time you reload the world again, it won't do it every time. So then you'll get your output on the action bar. I'll show you how to change that in a little bit. But then you're good to go. And then all you need to do is, if you want to check if they're pushing W, just go if predicate WASD and then whichever output you want. And then you can do run. You can also do unless if you wanted. So you could do like unless they are pushing W, do something. So there you go. That's how you can install it. So if that's all you wanted and you want to just throw in the data pack and use it for whatever you want, that's about all you need to know. But if you want to know how it actually works and you're a bit more, you know a bit more about how data packs work, this next part will be how it works a little bit more. So if we look in the main function, we have a couple stuff here. This is for our outputs. These are just kind of tests that you can use. This is showing it in the action bar. This is showing it in the title like you saw at the beginning. And then I have this fancy thing that I can show off in a little bit. So the first thing we do is some multiplayer friendly stuff to give you your own ID every time a player joins so that we can make it multiplayer friendly. But this is the basics for the WASD detection. So we go execute as at A, add at S, we run this function. So every player will run this individually. It'll branch off to each individual player so that everything in here is self-contained and it stays multiplayer friendly. Inside here, we got a bunch of stuff, but I'm gonna break it down as simple as possible, just the basic concepts. And then if you wanna know exactly how the code is, you can look at it and break it down if you want. So the first thing we do in this tick is we grab the players X, Y, and Z, and we store it onto fake players. So we grab our position 1, 2, and 3, which if we were to go in game and run data get entity at S position, it will give us our world coordinates, but it's got a lot of decimals or decimal numbers because it's like an extremely accurate version. So then to actually get all those decimal points, we increase the scale to like 100,000, which will just multiply that number by whatever this is, so that we just get those extra decimal points, because we want this to be really, really accurate. We also get the player's Y rotation, which is left and right, so that we know which direction they're facing, and then we can do some math to compare it to the direction they moved to see what key they actually pressed. So then in step 2, we reset the player's motion first so that in the next tick, it's like different for every tick. So first we set our motion. This is all on fake players, but then we apply it to the player later down the line. So we set the motion to 0, and then this command checks if our X position is the same as our previous position. So at the end of this loop, we actually apply our position to another fake player. So this is X, which is our current position, and then we apply it to a previous position. So then in the next tick, we can compare it and say if the player's current position right now is equal to the previous position, then that means they didn't move at all. So if like we were at coordinate 0, 0 before, and now in this next tick we're at 1, 0, we know we've moved because they're not the same. If we're still 0, 0 in both ticks, then we didn't move. So then what that does is just sets the score to like -999 just so that this doesn't actually happen. So then if we did move, this fails and we run this function. And this function takes our position and it compares it to our last position and gets our motion. So if we were at coordinates, say like 10, like x10, what we will do is get our current position, which let's say now we're at 11, and we put it on here. So now we have 11, and then we minus our previous position. So we are at 11 minus 10, which is we have only moved one block. And then we do that for z as well. So then our motion, if we moved diagonally like x1 and z1, so we moved like diagonal, we would get 1, 1 as our x and z motion. So what we do is we calculate the motion here, so we get where the player has moved. So then here we reset our WASD, which is on a score, which is actually how this works, is it gives a fake player A, S, D, or 0. So we reset whatever the previous thing was. Like if last tick we were pushing 0, then this, or we were pushing W, and it gets set to 1. We set to 0 here, so then the next tick we calculate it again. So again, we check if the player is moving, and then if they aren't moving, then this fails, and this fails, and we run this. So this is actually some code that I didn't write. I copied this from CloudWolf. He has his own WASD detection that I will link in the description. His is for when you're writing in a minecart. So his is probably a better version if you want to make some kind of like writable mob or something, like a dragon or something like that. He has a WASD detection for if you're writing a minecart. So his functions, he wrote all of this, and I've copied it. If you want more details on how this works, go check out his video. I'm not entirely sure how this works. It uses some Octane math that takes the motion that we just created, like we've moved 1 in the X direction, and then he also takes your rotation, uses some math to figure out what the WASD should be. So then if you are pushing A, like you moved left and you're looking in a certain direction, meaning you could have only pushed A, you get the fake player A's score to 1. So if you went left, you get left is 1. So then it does that for all of these. There's an extra one for W because of weird Minecraft rotation. So this is what actually sets the score to 1. And if we go in game, we can actually see this. So we set display the score to our sidebar. You can see we have our fake players, and if we actually push W, you can see W is at 1. And I can push A as 1, D is 1, and S as 1. So that's the function that actually does that and adds it to the score. And then once it's actually calculated what it should be, the last step is to go to apply output here, which then takes the WASD, that score, which is now 1, and makes it and applies it to our individual player W score. So there is actually a separate scoreboard that is W, and I am now getting 1 because at the end of the loop it takes the output that the game generated on those fake players and it applies it to this individual player running this command. So now it's local for each player. So now I could have my score be 1, and there could be another player in this game that is not pushing W, so they'll have their score 0. So it just calculates for each player individually. And then as for how I got this to be a predicate that you can use in the game, I just made a predicate. So like for W, for example, it's just a simple value check. That's just checking if the score is at least 1. That's all this predicate is. Then you just call this predicate and it's just checking the score. So that's how I turned it into a predicate. And that's about it if you just wanted back and forth, left and right detection, if the player's moving, like it's as easy as that. And then space is just literally the same thing, checking if you've moved or not. And it's just up and down instead of left and right and like X, Y, and Z. We just copy it for the Y as well. Just check if up is up and then down is down, which is in here. Where am I actually doing that? I forgot. Oh yeah, right here. This is calculating the Y. If it's just are they the same as is the player's current position equal to the previous position, and if it isn't, meaning they moved, then we just check did they go up or down. So it's just we minus or equals, is it above 0, meaning they moved up, because that's positive y, or is it -1 or below, meaning they moved down? So then there is a predicate for if you're falling down, which might be useful for like if you want to do some kind of falling thing. But that's all it is for the WASD, and then for spacebar, it's just checking did you move up. So that's the basics for if you're moving around and you just want to check an output this way. But then the hardest part that actually took forever for me to figure out is when you actually lock the player's position. So if you wanted to have the player hold still, like say you're making a menu, you want them to like not be able to move at all. I can like try to turn my mouse and it just teleports me back to the position. You want this to work as if they're not moving at all, but you still want to get their output. So I'm gonna explain how that works. It's a little bit complicated, but I'll try to explain it as best as I can. So if you look, there's actually a shulker on top of my head. So how this works is when we run the lock function, it places an armor stand and a couple other entities right where you are and forces you to constantly teleport. The shulker is added because I wanted it so that it's almost at a half slab height so that it forces me to shift. So I am not actually pushing shift right now, but because the block is too low for my player, if I like did the hitbox, it's too low for my player to actually be able to stand up fully because the shulker box is in the way. So it's the same as if you were like trying to shift under a half slab, but then you can't unshift. So it just forces you in this position. So then if I push shift, like I'm not actually moving at all because I'm already shifting. It just changes that I'm actually pushing the button shift, which shift detection is a different thing. It's just a scoreboard. If you know how to do that, you know how to do that. But then the space detection is because it's such a small check. Like I technically have not moved very much at all, but I've moved like 0.1 a block. If you look in the coordinates, I have actually moved like up a tiny bit. But if the shulker was like a perfect half slab above your head, then you wouldn't actually be able to jump. So I've actually moved it to being a half slab, like being as if it's like your height is like 1.5 or 2.5 blocks. But then I've moved the shulker just like 0.1 of a block a little higher so that there's just enough for it to detect that you're pushing space, but you still can't detect, you can't see that the screen is moving at all. So the actual summoning commands is this just checks if you already have the tag. If you do, it doesn't run it again, so you can't like spam it. So when you run the lock function, it gives you the tag lock. It teleports you to that location. That's for if you wanted to teleport the player somewhere else. Then it actually slows your movement down to as small as I can make it so that you are actually moving. If I did the attribute command, you can see I could make myself extremely slow. Base set like 0.001. You can see I can move ever so slightly, but it's slow enough to where if I teleported back and forth, you can't tell. So I did it to just where when I'm sneaking, I can still move ever so slightly just so that the data can still detect it. But it's so slow that you can't tell that the screen is moving at all. So we summon a marker at our position, and then there's some initial stuff to like link the entities together so that if there's multiple players, only one of them will each player will get their individual locking entities. So it spawns an armor stand with the shulker riding it, just because you can't really teleport a shulker off of the block grid without an armor stand. So it's an armor stand with a shulker riding it, but just think of the shulker. The armor stand's not really the important part. The marker is just to save where the player is positioned. So we teleport the marker to the player, and then in the looping function for WASD detection, if you have the tag lock, it's constantly going to teleport you to that marker. So that's how you lock the rotation. But then there comes the problem. If our locked position is right here, and let's say we move to the left because we push A, We then want to teleport the arm. We teleport the player back to the center because we want them to look like that they're not moving at all. The problem is, if you look at the output, I can then move to the left and it knows that move to the right and it knows that we've moved to the right. So we get A, D, A, D, A, D. So without some extra stuff that I've done, even if you pushed L, you would get, or even if you pushed left or A, if you went to the left, you go left, right, left, right, left, right, left, right, left, right, left, right, which is a bit of a problem if you want it to just, you're holding down left, you stay left, 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 left. You don't want it to go back and forth. So I did some clever stuff to actually do that. It's a bit tricky to explain, but I'll try my best. So first is we get our WASD by using this, which I explained a minute ago. We get like W is 1 or whatever. What then happens is if we are locked, we have the tag locked, so we are frozen, we add the tag success, meaning we have moved. So what will happen is if we actually have the tag success, it will not apply the position to our previous position. So if we were standing at 10 and we moved to 11, it's not going to change it to now we are at 11. It's going to stay at 10. So then when we start the loop again, here we say get our new position, which if we stop pushing the button or not, we get our new position. But because this one hasn't saved what our previous position was, we haven't moved in the previous tick. Like, that's kind of what we're faking. So like if we were at 10, we moved to 11, we didn't update, oh, now they're at 11, we're still at 10, so it thinks we didn't move at all. So it doesn't actually change anything. And so then we actually stop moving, and so then it cancels it out. So then instead of when we teleport to the right, it then updates as, oh, now we're right again. It just like, we didn't move at all because we moved left and then we moved back to the center. We didn't move at all. But then the problem becomes then you get a loop with the tick where it would say left, nothing, left, nothing, left, nothing, even if you're holding it down, which I wanted it to be as a constant output as possible. So then what we do is if we have the tag success, we have the tag buffer. We give the player the tag buffer. And at the end, we then remove success because we don't need it again. So now when the next loop, in the next tip, when this runs again, we get our data or whatever, we do everything again, so then we get what our movement is. But then here, the buffer will stop us from actually applying the player's output. So then what will happen is, instead of it updating, oh, W is 1, but then now W is 0 right here, we get our updated thing to say like we either have or haven't moved. We just save what the previous position, if we pushed A before, we just say, oh, keep pushing A even though maybe they moved, maybe they didn't. We just want it to last an extra tick. So then the next tick, we remove buffer. Where does it remove buffer? Right here. It removes buffer. So that basically just when we pushed left, it lasts for an extra tick so that we don't get like left, right, left, right, left, right, left, right. We just stay left. Because the next tick, we would have moved right because we teleported to the right. But because we want it to stay as left, when we push left, it will actually last for 2 ticks. And you can see this if we did this, like go execute as at A, if predicate W, run say W. If we are locked right here, we lock our position, I'm going to just tap W just once, and we still get 2 because it lasts for an extra tick. But I feel like that's a way better thing to have. Like, it just lasts for 2 ticks instead of it going WS, WS, or just WS, 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 or W, nothing, W, nothing, W. I'd rather have like 2 that it plays so that it's constant when we're holding it down. So that was a big roadblock that I had trying to get this thing to work. Thankfully, I made this. You don't have to know exactly how it works, but if you were curious, that was what I did to get it to work. So that's about it for this data pack. Again, the link is in the description if you want to download it. Let me know if you have any suggestions or any questions. I can answer them. And a little fun thing that you can do is in the download there will also be included a resource pack. that is just kind of a little fun fancy thing that I made. So we'll apply this texture pack and I'll just show you this. This is just for fun, like you don't really need this at all. I just thought this would be cool to show. And then if we go into the data pack, we can go back to the main function and change our output to legacy right here. And now if we do /reload, you can see we get a fancy little overlay here that shows what keys we're pressing. This is just because I wanted to make something fun. So if you wanted this to show up, all you need to do is just apply the texture pack and then switch the output to legacy in the function there, and it will display on our sidebar. Just as a little fun thing that isn't necessary at all, but I thought it'd be fun to make. So yeah, that's about it. Thanks for watching, and I'll see you next time. Bye.